Two of the world's most advanced fifth-generation fighter jets represent the pinnacle of modern aerial warfare technology. The American F-35 Lightning II and the Russian Su-57 Felon embody decades of military aviation innovation and strategic thinking. The F-35 Lightning II represents the United States' most ambitious fighter program, designed as a multi-role stealth fighter with advanced sensor fusion capabilities and network-centric warfare integration. The Su-57 Felon represents Russia's answer to fifth-generation fighter requirements, emphasizing air superiority, advanced maneuverability through thrust vectoring, and multi-spectrum stealth capabilities. This comprehensive analysis will examine how these two aircraft compare across multiple critical dimensions that define modern air combat effectiveness and strategic value. Our analysis will cover stealth technology implementation, operational roles and design philosophy, radar and sensor capabilities, maneuverability characteristics, cost considerations, and geopolitical implications. The outcome of this comparison has significant implications for the future balance of air power, military procurement decisions, and the evolution of aerial warfare doctrine in the 21st century. Stealth technology represents the cornerstone of fifth-generation fighter aircraft design. This invisible shield determines whether an aircraft can penetrate enemy airspace undetected or becomes a target for advanced air defense systems. Stealth technology works by dramatically reducing an aircraft's radar cross-section, minimizing its electromagnetic signature, and enabling penetration of heavily defended airspace where conventional aircraft would be detected and destroyed. The radar cross-section, measured in square meters, determines how visible an aircraft appears to enemy radar systems. This comparison chart shows the dramatic differences between various objects and aircraft types. The F-35 Lightning II employs comprehensive all-aspect stealth technology, maintaining an extremely low radar cross-section of just 0.0015 square meters from all angles. This makes it virtually invisible to most radar systems. In contrast, the Su-57 Felon focuses primarily on front aspect stealth, with a radar cross-section estimated between 0.1 and 0.5 square meters. While effective from the front, it offers limited stealth protection from side and rear angles. This numerical comparison reveals the dramatic difference in stealth capabilities. F-35's radar cross-section is between 67 and 333 times smaller than the Su-57's, making it exponentially more difficult to detect and track. These stealth differences create distinct tactical implications. The F-35's superior all-aspect stealth enables deep penetration missions and survival against multi-directional threats, while the Su-57's front aspect focus limits its effectiveness to defensive operations and requires careful positioning to maintain stealth advantages. The F-35 and Su-57 represent fundamentally different design philosophies, each optimized for distinct operational roles that reflect their respective nations' strategic priorities. The F-35 Lightning II is engineered as an offensive platform, designed to project power deep into enemy territory. In contrast, the Su-57 Felon serves as a defensive guardian, optimized to protect friendly airspace. The F-35's offensive design enables four critical mission types. First, it can penetrate heavily defended enemy airspace using advanced stealth technology. Second, it specializes in suppressing and destroying enemy air defense systems. Third, the F-35 conducts precision long-range airstrikes against strategic targets deep in enemy territory. Fourth, it serves as an intelligence platform, gathering critical battlefield information through advanced sensors. The Su-57's defensive philosophy centers on four primary missions. It excels in air defense operations, protecting Russian airspace from incoming threats. The aircraft is optimized for intercepting enemy aircraft and missiles. Additionally, the Su-57 conducts short-range airstrikes from within friendly airspace, avoiding deep penetration missions. It also engages ground targets that threaten Russian territory or Allied positions. This fundamental difference in operational philosophy is clearly illustrated when comparing these fifth-generation fighters alongside their contemporaries. Each fifth-generation fighter reflects its nation's strategic doctrine. The F-35 emphasizes stealth and sensor fusion for offensive operations, while the Su-57 prioritizes maneuverability and defensive capabilities. These operational roles reflect broader strategic doctrines. The F-35 embodies an offensive doctrine focused on power projection and deep strike capabilities, enabling multi-domain operations through network-centric warfare. Conversely, the Su-57 represents a defensive doctrine emphasizing territorial defense and air superiority. It focuses on threat interception and area denial, protecting Russian airspace and strategic assets. These fundamental differences in design philosophy and operational roles demonstrate how each aircraft serves its nation's specific strategic requirements and military doctrine. The effectiveness of fifth-generation fighters depends heavily on their ability to detect, track, and engage targets while remaining undetected themselves. Both the F-35 and Su-57 employ sophisticated radar and sensor systems, but with fundamentally different approaches. The F-35 Lightning II represents a revolutionary approach to battlefield awareness through advanced sensor fusion technology. This system integrates data from multiple sensors to create a comprehensive, real-time picture of the operational environment. The F-35 sensor fusion system combines data from radar warning receivers, electronic support measures, infrared search and track systems, and active electronically scanned array radar. This integration provides pilots with unprecedented situational awareness across multiple spectral domains. The Su-57 Felon takes a different approach, employing multiple specialized radar systems working in coordination. This multi-radar architecture provides comprehensive coverage across different frequency bands and operational scenarios. The Su-57 incorporates both X-band and L-band active electronically scanned array radars, along with an advanced infrared search and track system. Each radar operates in different frequency ranges, providing complementary detection capabilities against various target types. The L-band radar system represents a significant technological advantage for the Su-57. Operating at lower frequencies, L-band radars are particularly effective at detecting stealth aircraft, potentially negating some of the F-35's stealth advantages. L-band frequencies can detect stealth aircraft because they operate at wavelengths comparable to the size of stealth aircraft features. While stealth technology is optimized against higher frequency radars, L-band systems can achieve detection at significant ranges, providing early warning capabilities. Both aircraft employ infrared search and track systems, but these passive sensors offer unique advantages in stealth warfare. IRST systems detect heat signatures without emitting radar signals, making them undetectable by enemy radar warning receivers. IRST systems provide passive detection capabilities by tracking the infrared signatures of aircraft engines, exhaust plumes, and heated surfaces. These systems are particularly effective at shorter ranges and complement radar systems by providing silent detection capabilities. The ultimate effectiveness of these sensor systems depends on how information is presented to the pilot. The F-35's panoramic cockpit display integrates all sensor data into a unified interface, while the Su-57 employs traditional multifunction displays with advanced data correlation. The F-35 sensor fusion creates a single, comprehensive tactical picture that reduces pilot workload and enhances decision-making speed. The Su-57's approach provides detailed information from each sensor system, allowing experienced pilots to leverage specific sensor advantages in different tactical situations. Both aircraft represent advanced approaches to sensor technology, with the F-35 emphasizing automated fusion and the Su-57 focusing on multi-spectrum detection capabilities. These different philosophies reflect their respective operational doctrines and technological priorities. Fighter aircraft maneuverability represents a critical advantage in aerial combat, determining an aircraft's ability to outmaneuver opponents and survive in contested airspace. The Su-57 incorporates advanced three-dimensional thrust vectoring nozzles, allowing the aircraft to deflect engine thrust in multiple directions. This technology provides exceptional control authority during high angle of attack maneuvers. In close-quarters combat scenarios, the Su-57's thrust vectoring provides significant advantages. The aircraft can perform high angle of attack maneuvers, rapid direction changes, and post-stall maneuvers that would be impossible for conventional aircraft. The F-35, while capable in aerial combat, prioritizes beyond visual range engagement and network-centric warfare. Its design philosophy emphasizes stealth and sensor fusion over pure agility, making it less maneuverable in traditional dogfight scenarios. In close-range dogfight scenarios, the Su-57's superior maneuverability provides tactical advantages. The aircraft can maintain energy during tight turns and recover from high angle of attack situations that would compromise other fighters. However, modern aerial warfare increasingly emphasizes beyond visual range combat, where the F-35's stealth characteristics and advanced sensor systems provide significant advantages over traditional maneuverability-focused designs. The maneuverability comparison reveals fundamental design philosophies. The Su-57 prioritizes close combat agility through thrust vectoring, while the F-35 emphasizes stealth and network-centric capabilities for beyond visual range dominance. As aerial warfare continues to evolve, the relative importance of traditional maneuverability versus stealth and sensor capabilities will determine which design philosophy proves more effective in future conflicts. The economic factors and production capabilities of fifth-generation fighter aircraft reveal significant disparities between the F-35 Lightning II and the Su-57 Felon programs. The cost differential between these aircraft programs represents one of the most significant factors in procurement decisions for air forces worldwide. The Su-57 Felon is estimated to cost between 50% and 70% less than the F-35 Lightning II. While the F-35 program cost approximately $100 million per unit, the Su-57 is projected at $35 to $50 million per aircraft. Beyond acquisition costs, the Su-57 also demonstrates substantially lower operating and maintenance costs throughout its operational lifetime, making it an economically attractive option for budget-conscious air forces. However, cost advantages must be weighed against production capabilities and program maturity. The production numbers reveal a stark contrast between these two programs. The F-35 program has achieved remarkable production scale, with over 990 aircraft delivered to the United States and its international allies. The program has reached full-rate production with established global supply chains. In contrast, the Su-57 program has delivered approximately 20 aircraft to the Russian Air Force, with ambitious plans to reach 76 aircraft by 2028. However, the program has experienced significant production delays due to technical challenges and funding constraints. This delivery chart illustrates the exponential growth in F-35 production over the past decade, demonstrating the program's industrial maturity and manufacturing capability. The production scale differential has profound implications for global availability and operational presence of these aircraft systems. The F-35's extensive production has enabled deployment across multiple allied nations, creating a robust global presence and interoperability network. Partner nations benefit from shared logistics, training, and operational support systems. The Su-57's limited production constrains its global presence primarily to Russian operations, with minimal export potential due to production capacity limitations and international sanctions affecting technology transfer. Large-scale production directly impacts operational sustainability through enhanced spare parts availability, comprehensive training infrastructure, established maintenance networks, and higher operational readiness rates across the fleet. The cost analysis reveals a fundamental trade-off between economic efficiency and production maturity. While the Su-57 offers significant cost advantages, the F-35's established production scale provides operational reliability and global support infrastructure that may justify the higher investment for many air forces. Geopolitical factors play a decisive role in modern fighter aircraft procurement decisions. Nations must navigate complex international relationships, technology transfer agreements, and strategic partnerships when selecting advanced military systems. Russia has positioned the Su-57 as more than just an aircraft purchase. Moscow offers complete technology transfer and domestic production capabilities to potential buyers, making it particularly attractive to nations seeking to develop their own aerospace industries. However, this strategy faces significant challenges. United States sanctions represent a major deterrent for many nations considering the Su-57. Countries must weigh the benefits of technology transfer against potential economic and diplomatic consequences. Regional dynamics further complicate these decisions. Pakistan's acquisition of the Chinese J-35A fighter creates immediate pressure on India to maintain aerial parity. This arms race dynamic forces nations to make rapid procurement decisions based on their neighbors' capabilities. These geopolitical considerations create a complex decision matrix for nations. Countries must balance technological capabilities, cost factors, diplomatic relationships, and long-term strategic partnerships when selecting their next-generation fighter aircraft. The geopolitical landscape surrounding fifth-generation fighter procurement continues to evolve. Nations must navigate these complex international dynamics while ensuring their defense capabilities meet both current threats and future strategic requirements. Military aviation experts worldwide have extensively analyzed the capabilities of both fifth-generation fighters, providing crucial insights into their potential combat effectiveness and strategic value. The F-35's technological superiority stems from three critical advantages that fundamentally change modern air warfare dynamics. However, the Su-57 offers compelling advantages for nations prioritizing cost-effective air defense and domestic production capabilities. Future air dominance will be determined by four critical factors that extend beyond individual aircraft capabilities. The strategic choice between these aircraft ultimately depends on each nation's specific defense priorities, budget constraints, and geopolitical alignment. Expert consensus indicates that while the F-35 maintains technological superiority in most combat scenarios, the optimal choice depends on each nation's strategic doctrine, budget limitations, and long-term defense objectives. The future of air dominance will be shaped not by a single aircraft, but by how effectively nations integrate these platforms into their broader defense ecosystems.